Okay. So we've done completely randomized design, and we've done blocking. Now we're going to talk about experiment design that is blocking, but it's only blocks of two people, and you can only have two treatments in this design, and that's called matched pairs. So, um, so that's what it is. It's blocks of two, and in each block, each subject or experimental unit gets one of the experimental units in the block gets one treatment. The other experimental unit gets the other treatment. Okay. So here we go. Let me see if you can. I'll walk you through a blocking here. You want to test whether your new curriculum is effective on biology students. You probably don't want to test this, but the school district may want to test this. So you're going to give some students the old curriculum and some students the new curriculum. You're not going to do an observational study. You're going to do an experiment. Um, so how could we randomly assign treatments to students using a matched pairs design? So we probably don't want to divide people in these groups into males and females, because I don't think our biology curriculum would be decidedly different on males and females. We want to find some variable that we think is going to make a difference in our response variable. And then we're going to try to block on that with pairs. So yes, can you think of a response variable that might make a difference? Visual learners versus non-visual learners. That could work. That could work, but I don't know if my curriculum's. I'm going to direct you away from that because I don't know if my curriculum's actually going to be different for visual and non-visual. It's just going to be a new biology book versus an old biology book. So, but if it were in the experiments we've talked about before, where you had one that was computer and the other one was book, then that would be a great thing to block on. Yes. Ah, people with similar grades. So why would that cause a wide variety, a difference in our responses? I like it. I like it. But why would that? Why would we want to block on different previous grades? Yes. So students who study more are going to get the higher grades in the class. Students who don't study very much are going to get the lower grades in the class. So, and you might even say that there might be a difference in intelligence between those students who got the high grades from the previous science class and the low grades. It might be intelligence, it might be study skills, it might be maturity, something like that. So it does seem like a good idea to block on how students did in their previous course. Maybe we could get their GPA. Okay? So when I do a matched pairs design, I group people into pairs based on this variable, and then each person, each subject here, one subject gets one treatment, one subject gets the other treatment. If I'm giving the two different treatments within the pair, I want to have the pair look alike. My blocks are always homogeneous blocks. So I want to have my pairs of, of subjects in my matched pairs to be homogeneous also. Pardon me? So physically look alike if my experiment is physical. mentally look alike if my experiment is going to be on curriculum. So we're going to divide these students up into homogeneous pairs based on their last science class. So who should I put with the smartest kid? Okay, so we will pair up the smartest with the next smartest. And so on and so on. We'll do the next two smarter people until we get down to the bottom of the list where we're going to pair up the dumbest, oops, with the second dumbest. Why am I making these? Sorry. Oh, I was going to turn this thing around today and I forgot to do that. Okay. So that's how we're going to make our pairs. The next thing that we do is we randomly assign each treatment in the pair. So you could flip a coin. So if the coin is heads, the first person you see gets treatment 1 and the second person gets treatment 2. If it's tails, the second person you see gets treatment 1 and the other one gets treatment 2. So you want to make sure that the people that are getting the different treatments are randomly assigned to the treatments. Okay? So there's kind of your classic matched pairs. And we'll talk about how you analyze these matched pairs a little bit differently than if you do blocks instead. But there's another kind of tricky pairing that we want to do. And this is also called matched pairs. And we're going to test a deodorant. Okay, we got a new deodorant for men. So it's really strong. And it's not for boys, it's for men. That's what they always advertise, isn't it? So matched pairs designed for this experiment might be a little bit different. So what kind of variables would there be that would affect how well this deodorant works on men? Yes. Amount of exercise. We can certainly pair these people with somebody that does the same amount of exercise they do. Yes? Age. Age is a good one. We could pair the young man with another young man, and then the 65-year-old guy is going to be paired up with the 67-year-old guy because they kind of have the same sweat range. Yes, sir? We could test the amount they sweat, and we could put the heavy sweaters with another heavy sweater and the light sweaters with the other light sweaters. Yes. What's that? Race. Races certainly can be an issue for sweating. Yes, apparently some races sweat more than others. Yes. Do you have another idea? Their locations. The people that live in San Mateo versus the people that live in Pacifica, where I live, and there's no reason to sweat there. It's always cold. Except yesterday. It was nice at the beach. So there are many, many variables that we could block on, but there's the best variable of all if you're talking about testing somebody and you want to test some person for both treatments. You can be your own pair. so I don't gotta match you up with another male that looks and acts and has the same environment that you do.